The objective of this lesson is for students to relate their prior knowledge of volume to understanding and calculating the volume of a right rectangular prism with fractional edge lengths. In previous lessons, students calculated the volume of right rectangular prisms with whole number edge lengths using the formula volume equals length times width times height. Today, they will extend their knowledge to calculating the volume using fractional edge lengths. Let's begin with the problem. Jason is using sugar cubes with 1 centimeter edge lengths to create a model of a building. First, he organizes a layer with a 4 centimeter length and a 2 centimeter width. He then creates one more identical layer by placing the second layer on top of the previous layer to complete the building. Build a model of Jason's building with centimeter cubes. What shape is he building? What is the volume of the sugar cube model? Let's build the model with centimeter cubes. The base layer has 4 cubes for the length and 2 cubes for the width. This means there will be 2 rows of 4 cubes. The problem states he creates 2 identical layers. Place another layer on top. The shape is a rectangular prism. The second part of the problem is to find the volume of the model. The dimensions for length and width were given. The unknown dimension is the height. If each cube has an edge of 1 centimeter and there are 2 layers, then the model is 2 centimeters high. Let's draw the model on graph paper to calculate the volume. Each layer has the dimensions of 2 by 4. Draw a 2 by 4 rectangle to represent the area of the base. The area of the base can be calculated by counting the squares. There are 8. Or the length and width can be multiplied. 4 times 2 equals 8 square centimeters. This is just the base of the model. In order to find the amount in 2 layers, or the volume in the model, multiply the length times the width times the height. 4 times 2 times 2 equals 16 centimeters cubed. Or the area of the base multiplied by the height is also equal to the volume of the prism. 8 times 2 equals 16 cubic centimeters. Now let's consider the edge of each cube to represent only 1/2 of a unit. What is the area of the base of each cube? 1/2 of a unit times 1/2 of a unit equals 1/4 of a square unit. The area of the base when the edge lengths were 1 unit is larger than the area of the base when the edge lengths are 1/2 unit because the edge lengths are smaller. Therefore, the area will also be smaller. If the edge is 1/2 unit, the volume of the cube would be length times width times height, or 1/2 unit times 1/2 unit times 1/2 unit, which equals 1/8 cubic units. The volume of the cube with a 1/2 unit edge is smaller than the volume of the cube with a 1 unit edge because 1/2 is a smaller amount than 1 whole. Jason created a model that had a base of 2 units wide by 4 units long. How would this be represented on graph paper if each square edge was equal to 1/2 unit? The width would need to have 4 squares because 2 halves are 1 whole and 4 halves are 2 wholes. The length would have to be 8 squares because 8 halves are equal to 4 wholes. The area of the base would be the length times the width. 8 halves times 4 halves equals 32/4 square units, or 8 square units. The area is still the same as the model completed previously. In order to create a model that is 4 units long by 2 units wide by 2 units tall, using cubes with 1/2 unit edges, how many layers will there need to be made? There will need to be 4 layers of cubes because each cube is 1/2 unit in height and 4 halves equal 2 wholes. The volume is found by multiplying the length, width, and height. 8 halves times 4 halves times 4 halves equals 128 eighths cubic units, or 16 cubic units. This is the same volume as before. This is because fractions are numbers, so they can be applied to the formulas, just as whole numbers can be applied to the formulas. The objective for this lesson was for students to relate their prior knowledge of volume to understanding and calculating the volume of a right rectangular prism with fractional edge lengths. We met this objective by using centimeter cubes and graph paper to model a rectangular prism with each edge representing 1 unit, and again with each edge representing 1/2 unit. We found that the formulas for area and volume also work with fractions because fractions are numbers.